All right, tell me what this is, please. No, I didn't say read it to me. I said tell me what it is. It's a general form of a quadratic, right? Okay. Just to go back over some stuff that I already know that you know, but that is going to be important for us today. Um, where is the A? I mean, obviously you can see the A right here, but where is it always? It's with the x squared, right? That's our A. Where is the B always? In front of the x. And where's the C always? It's by itself. There's no variable with it. It's our constant, right? Now, in general form, what is a quadratic equal? 0. And so if we're doing what we're doing today, and we start with an equation that doesn't equal 0, what do we actually have to do first? We have to get it equal to 0 first before we can do anything that we're going to do today. Okay? Does that make sense? Okay. So today we're going to talk about the discriminant. And the discriminant is actually a formula. Now you're going to need to know it, but I'm not really asking you to memorize it per se, although you will, because we're going to use it a lot. As much as we're going to use it today, we're going to use it even more in the next couple days. So it's not something to worry about that you're going to have to memorize, because you're just going to know it eventually. Is everybody okay with that? So b squared minus 4ac. So when I give you a quadratic, you know where all this stuff is, right? Where did the 4 come from? Do you know? Yeah, you don't have to. Not yet. You don't have to know where it came from yet. You have to know that it's given. It's part of the formula for discriminant. Is everybody okay with that? In the next couple days, I'll show you where it comes from. Is that fair? Okay, but for now, just know that 4 is part of the formula. You okay with that? Okay. Excuse me. Well, it's all fine and good to know a really great formula, but it doesn't help if we don't know what it does. Okay? So let me tell you a little bit about the discriminant. Okay? Before I tell you about the discriminant, let's talk about some solution information. Okay? If we're solving a quadratic, how many solutions should we get? How do you know we should get 2? Fundamental theorem of algebra, right? Fundamental theorem of algebra says we should get 2 for a quadratic. Okay? Do you know what they look like? Do you remember what a solution to a quadratic looks like? So x equals, so what does that mean? Where the parabola crosses the x-axis, right? So give me some possibilities. What could it look like? So like this, right? That's kind of a goofy looking parabola, but use your imagination, right? How many solutions are there right here? 2 solutions. I'm okay with that for now. We're going to fix that in a minute, okay? But I'm okay with it for now. What's another possibility? Upside down, but still crossing the x-axis twice, right? I'm okay with that. Oh, so if it only crosses once? How would a parabola only cross once? It has to be a parabola, right? So it has to be this shape, either this way or upside down, right? But how could it only cross the x-axis once? Oh, yeah. If the vertex touches the x-axis just like that, right? So you want me to say one solution? I'm okay with that. We'll fix it for now, or in a minute. What's another possibility? Oh, it doesn't cross the x-axis? Is that possible for it to not cross the x-axis? What would that look like? Oh, just like higher? Or like lower. It could be down here, right? How many solutions are those? After yesterday? Can you tell me how many solutions there are? 2, right? Now we need to go back and fix the other 2. Because remember I told you I'm okay with it for now, but we got to fix it in a minute. How many solutions are there right here? There are two, but they are two real solutions. You can see them, can't you? How many solutions are there right here? One real, and I need you to also remember that it's a double root. You remember us talking about that before? It's a double root. There's actually two solutions. It's just the same one twice. So it's called a double root, but it's one real solution. So now tell me how many solutions are here. To what kind? Uh-huh. It really doesn't matter if you like it or not. I just need you to get over it and do it. Is that okay? It does throw you off, and that's fair. It's not something you've ever seen before, right? Literally yesterday was the very first time you've ever seen it. That's okay. You can learn new stuff, right? Okay. Yeah, he knows I was just kidding. Yeah, it's okay. So now let's use the discriminant and match up some stuff with these. Okay? So let me give you an equation. Here's the first equation we're going to talk about. X squared plus 5x minus 6 equals 0. X squared plus 5x minus 6 equals 0. Okay? So first thing we need to do is identify our A, our B, and our C. A equals what? Close. 1, right? If it was 0, it wouldn't be there because 0x squared is just 0, and then it's not a quadratic anymore, right? Okay. What about B? 5. And what about C? -6. Very good catch. You got to keep the signs with the numbers, right? So now I have to fill in B squared minus 4AC. Well, what's B squared? So what is that? 25. If it's something like that I can do in my head, I want to. Okay? Minus 4 times A, which is 1, times C, which is -6. So I have 25 minus 4 times 1, 4. 4 times -6, -24. Now, did you notice what I did? From here, I wrote down 25 minus, and I took care of that. So what I had left was 4 times 1 times -6. Okay? If you're not careful, that negative sign is going to mess you up. So I wrote down 25 minus and got rid of it. Got it out of my head. And then 4 times 1 times -6 is -24. Well, what happens now? I'm adding, right? Because minusing a negative is adding. What is 25 plus 24? 49. So first of all, the value of the discriminant is 49. So that is like my first answer. Okay? Some of the questions on the homework, they just say, find the value of the discriminant. And if that's what they ask, we're done. Okay? Some of the questions on the homework say, find the discriminant and describe the number and type of solutions. From this one number right here, you can tell me if there's 2 real solutions, 1 real solution that's a double root, or 2 imaginary solutions. Without putting this in the calculator, without actually solving and knowing what the solutions, you can know just by looking at this number. Isn't that cool? So what about this number is going to tell me whether it's 2 solutions, 1 solutions, or 2 imaginary? Sorry, 2 real, 1 real, or 2 imaginary. Well, this number right here happens to be positive. If this number is positive, thinking about these 3 graphs over here, which one of these graphs do you think that this fits with? 2 real. That's exactly right. 2 real solutions. Because it's positive, you're going to be able to find 2 real solutions. 2 real solutions. Any questions about that? You ready to try another one? Okay. 3x squared minus 6x plus 3 equals 0. 3x squared minus 6x plus 3 equals 0. What do we do first? Identify A, B, and C. Find A, B, and C. You are correct. What is A? 3, and B? Negative 6, and C? 3. B squared minus 4AC. In this problem, what is B squared? What is that? 36, right? Now, guys, have I touched a calculator so far? No. And it's not that I don't want you to, it's that this particular question makes me nervous. Like this exact question makes me nervous for you. Because some of you still kind of use your calculators as like little security blankets. Not judging, not judging. Okay? But you still use your calculator as little security blankets. And I need to show you why this calculator is not always a good security blanket. Okay? Well, I'm going to have to zoom in so you can see what I'm typing. So what you just told me was that negative 6 squared was what? Who's wrong? You or the calculator? So the calculator did exactly what you asked, or what we asked. It squared a negative 6. No, it didn't, did it? It squared a 6 and then multiplied by a negative. Is that what we meant to ask it to do? What we meant to ask it to do was this. And if you forget to put in those parentheses, you're going to get the wrong answer every time. That's why I'm hoping that you'll realize, first of all, that we can do some math in our head without panicking, right? And second of all, I just want you to go ahead and do that, right? Negative 6 squared. You know a negative times a negative is going to be a positive, right? Write it down and go on. I'm purposely not writing a parentheses, negative 6 parentheses squared, because I don't want us to get hung up on that. Okay? There's lots of ways to make mistakes. I don't want to show you all the ways to make mistakes. I want to show you how to do it right. Does that make sense? Now, I'm choosing to show you a way to make a mistake on this problem, because if we don't get it right today, the next couple days we're doomed. Doomed. Okay? Minus 4 times 3 times 3. Now, just as a reminder, does it matter what order you multiply in? So is it easier to say 4 times 3 is 12 times 3? Or is it easier to say 3 times 3 is 9, 9 times 4 is 36? You did that one a whole lot faster than the first way, right? It doesn't matter what order we multiply in as long as we get all the numbers there multiplied. Okay? Does anybody know what 36 times 30 or minus 36 is? Oh, excellent. So first of all, if it says find the discriminant, find the value of the discriminant, we got it, right? What does this value of the discriminant tell us about the solutions, though? If it's 0, that's this one right here. One real solution, it's sitting right on the axis. Okay? One real solution. But we're also going to write double root. This tells me you know that there's really two solutions, but they are the same, right? So mathematically, like when we write it down, it's one answer, but there's two of them. Everybody okay with that? This is our proof that we know what fundamental theorem of algebra says. Okay? One more example? Yes, no? Okay. 8x squared plus 6x plus 5 equals 0. Okay, so it equals 0. That's a good thing to point out. Oh yeah, this equals 0, so that's great, so we don't have to do anything. If it didn't equal 0, we would need to make it equal 0, right? And now, identify A, B, and C. A is what? 8. B is what? 6. And C is 5. Good. B squared minus 4AC. What's B squared? 36 minus 4 times 8 times 5. Now, what I told you about a second ago is really going to come into play here, isn't it? Which one's going to be easier? 4 times 8 times 5? 5 times 8 times 4? Or 4 times 5 times 8? Definitely 4 times 5 times 8, right? Could you do any of the 3 combinations that I just said? Yeah, for sure. But 4 times 5 times 8, we don't even need a calculator for that, do we? 4 times 8 is, or sorry, 4 times 5 is 20, and 20 times 8 is 160. Now, am I going to be mad at you if I see you putting in your calculator 4 times 8 times 5? No, absolutely not. Okay? Like I said, some of us still need it as a little security blanket. Oh, that's all right. What is 36 minus 160? Negative what? Negative 124. So if it says find the discriminant or find the value of the discriminant, we're done, right? But if it says find the value of the discriminant and describe the number and types of solutions, what do you notice about this number? It's what? It's negative. And didn't we work on this yesterday? Negatives? Didn't we do that? What did that tell us? Two imaginary solutions. So without even knowing what the actual answers for this are, I know that this graph doesn't cross the x-axis. Without looking or without knowing exactly what the solutions to this one are, I know that the graph sits on the axis. Without looking or knowing what the solutions are, I know this one crosses the axis 2 times. Does that make sense? Okay, so on your homework, like I said, there's some questions that say, find the discriminant. If it says find the discriminant, this is the number, that's the answer. Okay, if it says find the discriminant and state the number of types of solutions, you've got to find the number so you know the number and the type of solutions. The number is 2, the type is real. The number is 1, the type is real, but you got to have double root there. The number is 2, the type is imaginary solutions. Does that make sense? Any questions?